October 23, 1944. The Palawan Passage is a narrow strategic corridor, and on this morning it becomes a kill box. The heavy cruiser Maya is steaming into the teeth of an American ambush. The submarines USS Darter and USS Dace have established a firing solution on the Japanese center force. While Darter engages the heavy units Atago and Takao, the USS Dace selects Maya as its target. This is not 1942. The era of defective American torpedoes is over. When Dace fires a spread of fish, they do not bounce off the hull or run deep. They track true. In the opening moments of the ambush, Dace fires a 6-torpedo salvo. 4 strike Maya's port side in rapid succession. 1 in the forward chain locker, another opposite number 1 turret, a third in number 7 boiler room, and the last in the aft engine room, while 2 run wide. This is not a disablement. It is a distributed kill pattern from bow to stern. What explains why a heavy cruiser weighing over 13,000 tons vanishes so quickly? You must understand the physics of torpedo shock. This is the mechanics of shock loading and impulse transfer. A torpedo does not simply punch a hole in a steel plate. When the warhead detonates against the hull, it converts a massive amount of chemical energy into a rapidly expanding gas bubble. Because water is only slightly compressible, it transmits the blast like a hammer blow. The shockwave travels through the liquid and strikes the hull with a velocity that exceeds the speed of sound in water. This energy transfers directly into the ship's structural frame. The keel, the ribs, and the longitudinal girders are subjected to a violent whipping motion. Steel that is designed to withstand the slow heave of ocean waves cannot handle the high-frequency snap of a high-explosive event. The rivets shear, the welds crack. The watertight bulkheads, which are the only defense against flooding, are compromised instantly. When 4 of these events happen simultaneously across the length of the hull, the ship loses its longitudinal strength. It ceases to be a rigid floating body and becomes a broken collection of compartments fighting a losing battle against the sea. The damage reports, had there been time to file them, would have been terminal. The hit to the number 7 boiler room and the aft engine room cuts the power. The pumps fail. The hydraulic pressure for the rudder and guns vanishes. The hit to the chain locker and turret 1 destroys the forward buoyancy. The ocean rushes in not through leaks, but through gaping structural wounds. The calculation of survival changes from hours to minutes. Maya does not linger. She begins to list and settle immediately. There is no time for counterflooding. There is no time to shore up bulkheads. The fires ignited by the explosions begin to consume the interior spaces, turning the dying ship into a furnace even as she sinks. Evidence of this thermal trauma remains visible on the wreck today. On the bridge structure, a steel ladder appears warped and melted, twisted into a shape that defies its original geometry. While corrosion plays a role in this deformation, the damage speaks to the violence of the final moments on the surface. This is a fringe detail that hints at the terrifying environment inside the superstructure as the ship began its final plunge. The end comes with horrifying speed. From the first hit to capsize and loss, the timeline is measured in minutes, often reported as roughly 7. It is a logistical impossibility to clear a ship with roughly 1,100 crewmen in a handful of minutes. 336 officers and men are pulled down with the ship or killed in the initial blast. The survivors are left in the oil-slicked water of the Palawan Passage. The heavy cruiser falls away from the light. She leaves the war behind and enters a new domain where the enemy is no longer the U.S. Navy, but the physics of the planet itself. She has vanished from the strategic map, deleted from the order of battle. For 75 years, her location remains a coordinate on a chart, a theoretical point where history stopped. But the ocean is deep and gravity is patient. She falls not into oblivion, but into a specific layer of the abyss that will hide her until the technology of the 21st century is ready to find her. 6,070 feet, 1,850 meters. That is the vertical distance between the sunlight of the Palawan Passage and the sediment where the heavy cruiser Maya now rests. When the research vessel Petrel located the wreck in late June 2019, publicly announced on July 1st, the team was not looking for a ship that was merely hidden by darkness. They were looking for a vessel that had been claimed by the crushing weight of the ocean itself. The wreck's condition is dictated by the physics of hydrostatic pressure. On the surface, a warship exists in an atmosphere of 1 bar. At this depth, the environment changes into a hydraulic vise. The weight of the water column above the ship exerts a pressure of nearly 2,700 pounds per square inch. This force is relentless and omnidirectional. It does not push from one side like a wave or a torpedo blast. It squeezes from every possible angle simultaneously. When a ship sinks, any compartment that is sealed tight with air inside becomes a potential bomb. The pressure differential between the exterior water and the interior air grows rapidly as the hull descends. If the steel bulkheads cannot withstand the load, they implode. The hull is crushed inward until the pressure equalizes. However, if the ship is already flooded, or if the water can rush in fast enough to match the descent, the structure survives. The water inside pushes out with the same force that the ocean pushes in. The net force becomes zero. This mechanic explains one of the most haunting anomalies found on the Maya wreck. Amidst the twisted steel and shattered plating, there are objects of extreme fragility that remain perfectly intact. On the bridge structure, a pair of binoculars and a crewman's headset are still hanging from their original storage hooks. The rubber cord of the headset is draped naturally, and the lenses of the binoculars are unbroken. This creates a visual paradox. The steel hull of the cruiser has been torn apart by high explosives and impact forces, yet a delicate piece of glass and rubber survives. This is because the headset is not a sealed pressure vessel. The water permeated it instantly. It felt no crushing force because there was no pressure difference to resolve. The deep ocean is a hostile environment, but its hostility is selective. It destroys anything that resists it and preserves anything that surrenders to it. The heavy cruiser itself did not surrender gracefully. The descent was violent. As the 13,000-ton mass accelerated toward the bottom, the drag forces acting on the hull were immense. The structural damage caused by the torpedo hits at the surface created weak points that could not withstand the hydrodynamic stress. The bow section, already compromised by the hit to the chain locker, failed completely. ROV imagery shows the bow detached and inverted near the stern of the main wreck, but exterior footage alone cannot prove exactly when the separation occurred. The most likely reading is that the bow separated during the descent and drifted independently through the water column before settling inverted near the stern. The sharp prow that once cut through the waves is now buried in silt, and the imperial chrysanthemum is missing, either dislodged in the separation or swallowed by the bottom. The separation of the bow confirms the severity of the initial attack. The steel plating at the break point is jagged, evidence of the catastrophic failure of the longitudinal girders. The ship did not just sink, she broke her back. The main section of the hull hit the bottom with enough energy to bury itself deep into the sediment line. The current at this depth is slow, and the visibility is clear, allowing the camera to document the scale of the destruction. But the severed bow is only a piece of the puzzle. While the depth and pressure define the environment, they do not define the identity of the ship. To confirm that this is indeed Maya and not one of her sisters in the Takao class, we must look away from the broken bow and turn our attention to the massive structure that still towers above the sea floor. The silhouette of a Takao-class heavy cruiser is unlike anything else in naval history. The bridge structure is a fortress of steel, a massive castle rising from the deck that was designed to house the complex command facilities needed for a fleet flagship. When the lights of the research vessel Petrel cut through the gloom at 6,000 feet, this structure is the first thing that confirms the general identity of the wreck. Despite the violence of the sinking and the 75 years of submersion, the bridge of the Maya is remarkably well preserved. It looms out of the darkness, encrusted with rusticles and covered in a fine layer of silt, but the architecture remains distinct. The windows of the compass platform are visible, staring out into the abyss like hollow eyes. The instruments inside, while shrouded in sediment, are still mounted in their frames. The fire control platform, located high above the main deck to direct the gunnery, retains its shape. However, the survey of this structure is governed by a strict set of physical and operational constraints. This brings us to the engineering reality of deep ocean robotics. The remotely operated vehicle, or ROV, is not a free swimming entity. It is tethered to the surface ship by a long armored cable that carries power down and data up. This umbilical is the lifeline of the operation, but it is also the greatest liability. Navigating an ROV around a complex wreck site like Maya is a high-stakes game of three-dimensional geometry. The pilot must maneuver the vehicle closer to the steel to get high-resolution imagery, but he must never cross the threshold of the interior. This is the hard limit of forensic survey work. You cannot enter the ship. The risk of the tether snagging on a jagged piece of torn plating or a collapsed bulkhead is too high. If the cable fouls, the ROV is trapped. At 1,800 meters, there is no rescue diver. The vehicle is lost and the survey is over. Furthermore, the camera has its own limitations. Light does not travel far in water. The high-intensity lead banks on the vehicle can only illuminate a few dozen feet in front of the lens. Beyond that, the water absorbs the photons, creating a wall of black. The pilot is effectively driving a truck through a blizzard at night, seeing only what falls within the narrow cone of the headlights. This phenomenon, known as backscatter, occurs when the light reflects off the suspended particles in the water, creating a glare that can obscure the details of the wreck. Despite these limits, the cameras reveal striking details on the exterior decks. Near the bridge structure, the survey team locates a specific anomaly that speaks to the chaotic configuration of a warship in late 1944. Lying on the deck next to a triple 25mm anti-aircraft mount is a detached gun shield. This is a steel plate designed to protect the gun crews from strafing fire and shrapnel. It is rare to see these shields intact and lying flat on the deck. Usually they are blown away by the blast or disintegrated by corrosion. Its presence here is a fringe technical detail that suggests the mount was either in the process of being serviced or the shield was torn loose by the hydrodynamic drag as the ship sank, fluttering down to land on the deck like a leaf. It is a small piece of steel, but it adds texture to the forensic scene. The survey continues to pan across the superstructure. We see the heavy rangefinders, the optical eyes that once calculated the firing solutions for the main battery. They are rusted, their internal optics likely crushed or flooded, but they remain fixed to their mounts. We see the ladders, the platforms, and the walkways where the crew once stood. The preservation is eerie. It looks less like a pile of scrap and more like a ghost ship sailing through a void. But visual preservation is not the same as positive identification. The massive bridge confirms that we are looking at a Takao-class cruiser, but there were 4 ships in this class: Takao, Atago, Maya, and Chokai. To the untrained eye, they are identical. To the naval historian, they have subtle differences. The bridge tells us the family, but it does not tell us the name. To prove that this is Maya and not one of her sisters who also met their ends in the waters of the Pacific, we must find a specific structural modification. We need to find a piece of the ship that does not exist. In late 1943, the Japanese Naval Command faced a tactical reality that could no longer be ignored. The threat to their surface fleet was no longer other ships, but American naval aviation. To counter this, they made a specific engineering trade-off that would ultimately distinguish the Maya from her sisters in the Takao class. They decided to sacrifice offensive firepower for defensive density. This decision created the forensic fingerprint that allows us to identify the wreck today. This is the concept of identification via refit. When a class of warships is built, the vessels are identical. But as the war progresses, damage repairs and doctrinal shifts cause their configurations to diverge. A welded patch on a hull, a modified mast, or a relocated gun mount becomes a permanent physical record of that ship's operational history. For the historian, the ship is no longer defined by its original blueprints, but by its wartime scars. For Maya, the most significant scar was the removal of the No. 3 main battery turret. This was a massive twin 8-inch gun mount located directly forward of the bridge structure. The engineers removed the heavy machinery and the armored barbette to clear the deck space. In its place, they installed a lighter steel platform designed to hold heavy anti-aircraft weaponry. Her sisters, Atago, Takao, and Chokai, retained their No. 3 turrets for most of their careers or had different modification patterns. When the ROV glides over the forward deck, the pilots are looking for this specific absence of steel. As the camera tracks aft past the No. 1 and No. 2 turrets, it reaches the position where the No. 3 turret should be. It is not there. The barbette is gone. Instead, the lights reveal the makeshift anti-aircraft platform installed during the refit. This structural anomaly is the smoking gun. It confirms that the wreck is indeed the Maya. On this platform, we find the triple 25mm gun mounts that replace the main battery. But we also find something else. Resting directly on top of one of these anti-aircraft guns is a massive length of anchor chain. This creates one of the most surreal images of the entire survey. The chain is not where it belongs. It has been ripped from the forward locker, likely during the violent explosion caused by the first torpedo hit, and thrown backward by the force of the blast or the flow of the water. The chain is draped over the delicate gun mount like a giant iron snake. The links are thick and heavy, dwarfing the barrels of the 25mm cannons beneath them. It is a juxtaposition of brute industrial weight against precision machinery. The gun mount, remarkably, has not collapsed under the load. It holds the weight of the chain, frozen in a tableau of destruction. This specific detail, the chain draped over the refitted gun platform, serves two purposes. First, it reinforces the identification. We are looking at the specific 25mm mounts that only existed on Maya. Second, it visualizes the chaotic energy of the sinking. For that heavy chain to end up draped over a gun mount located dozens of feet aft of the locker, the ship must have undergone a violent convulsion as she went down. With the identity of the ship locked by the missing No. 3 turret and the unique anti-aircraft arrangement, the survey has achieved its primary objective. The evidence is conclusive. This is the Maya. But while the midship section tells the story of her identity, the aft section tells the story of her death. As the ROV moves past the bridge and heads toward the stern, the condition of the wreck deteriorates. The preservation of the forward superstructure gives way to total structural failure. We are moving from the forensic evidence to the physical consequences of a broken spine. The geometry of the seabed at 1,800 meters is usually flat and featureless, a plane of sediment that has not changed for millennia. But at the stern of the heavy cruiser Maya, this geometry has been violently interrupted. While the bridge structure stands defiant and the bow lies capsized nearby, the aft section of the ship offers a different lesson in material failure. It serves as the final argument against any possibility of recovery. As the cameras of the ROV move past the midship section, the preservation of the hull vanishes. The stern is not merely damaged, it has undergone a total structural collapse. To understand why this happened, you must look at the mechanics of a sinking ship as a failure of a longitudinal girder. A warship is essentially a long steel beam designed to be supported evenly by the water. When the torpedoes struck the aft engine room and the boiler room, they destroyed the buoyancy in the rear third of the ship. This created a massive imbalance. As the stern lost buoyancy, it became a dead weight, dragging the rest of the hull down. The steel plating, weakened by the explosions and the subsequent fire, could not support the tensile load. The girder snapped. When the ship impacted the bottom, the structural integrity of the stern was already compromised. The force of the collision with the seabed finished the job. The hull plating buckled and folded in on itself, burying the propellers and the rudder deep into the mud. This phenomenon is known as progressive structural collapse. It is not a clean break. It is a cascading failure where one load-bearing component gives way, shedding its weight onto the next component, which also fails. The result is what we see today. The fantail of the cruiser is pointing sharply upward, angled toward the surface, while the main body of the stern is crushed downwards. The steel has lost its memory of the original form. It is no longer a hull, it is a tangled mass of corroded metal held together by gravity and friction. This condition creates a definitive geometry trap for any salvage engineer. To lift a ship, you need strong points to attach chains or lifting bags. You need a hull that can withstand the tension of the lift. Maya possesses neither. If you were to attempt to attach a lifting cable to the stern, the steel would likely tear away like wet paper. The structural continuity required to transfer the lifting force from the attachment point to the rest of the mass simply does not exist. Furthermore, the mud itself acts as an anchor. The suction of the sediment, accumulated over 75 years, adds thousands of tons of resistance to the equation. To break this suction would require force levels that would disintegrate the remaining structure. The ship has become part of the geology. Amidst this wreckage, there is a fringe detail that highlights the precarious nature of the site. On the tilted deck of the collapsed stern, the survey team locates the depth charge racks. These were weapons designed to kill submarines like the USS Dace. They remain in their ready positions, cylinders of high explosives sitting in their steel cradles. What is remarkable is the angle. The rack is tilted sharply, conforming to the collapsed geometry of the deck, yet the depth charges have not slid out. They are held in place by their locking mechanisms or perhaps fused to the rack by decades of corrosion. They sit there, suspended in a state of potential energy, defying the gravity that pulled the rest of the ship apart. This visual confirms the operational decision for the mission. This is a survey, not a salvage operation. The objective was to find the ship, identify her, and document her condition. That objective has been achieved. We have found the Maya. We have proven her identity through the missing number 3 turret. We have mapped the debris field. To go further to attempt to disturb the site would be technically impossible and historically irresponsible. The stern is a tomb, collapsed in on itself, protecting the spaces where the crew fought to save the ship. The decision is made to leave her as she is. The ROV pulls back, widening the shot to take in the full scale of the devastation. The mission shifts from discovery to remembrance. But before the lights are turned off and the vehicle begins its long ascent to the surface, there is one final check to be made. We must assess the legacy of the site and the silent threat that remains active in the darkness. The final assessment of the heavy cruiser Maya is not determined by the steel of her hull, but by the chemistry of her cargo. While the structural collapse at the stern prevents recovery, the racks of depth charges sitting on the fantail represent a risk shadow that extends far beyond the physical boundaries of the wreck. These cylinders are not merely historical artifacts. They are dormant canisters of high explosive energy that have been subjected to 75 years of immersion. To understand the danger of a warship that has been on the bottom since 1944, you must understand the concept of ordnance hazard in a saltwater environment. There is a common misconception that water neutralizes explosives. It does not. The explosive fillers used in naval munitions, such as trinitrotoluene or picric acid derivatives, are remarkably stable. They do not dissolve in water. Instead, the metal casings corrode, exposing the chemical core to the ocean. In some cases, this exposure creates a reaction that makes the explosive more sensitive to friction or shock, not less. The detonators may be rusted into uselessness, or they may be hair trigger springs held back only by a thin layer of oxidized metal. A remotely operated vehicle bumping into one of these racks or a salvage claw attempting to cut through the deck could provide the activation energy needed to initiate a detonation. At a depth of 6,000 feet, a sympathetic detonation of a depth charge rack would create a shockwave capable of destroying the research vehicle and obliterating the forensic evidence at the stern. The site is not just a grave, it is a minefield. The team records the ordnance layout, logs the hazard, and backs the vehicle away from the stern. The rule here is procedural. Document, do not disturb. As the vehicle prepares to leave the bottom, the cameras pan forward for one final look at the main battery. It is here that we find the most poetic and striking image of the entire expedition. The number 2 turret, located just ahead of the bridge, is frozen in a posture of extreme defiance. Both 8-inch gun barrels are elevated to their maximum limit, pointing almost directly up toward the surface 6,000 feet above. This is likely not a sign of a final desperate attempt to shoot down an aircraft. The heavy main guns were too slow to track the American planes effectively, and the doctrine would have prioritized the anti-aircraft batteries. Instead, this is likely a result of mechanical failure during the sinking. As the hydraulic pressure bled out of the system following the engine room hits, the heavy britches of the guns inside the turret lost their support. Gravity pulled the heavy rear ends of the guns down, which leveraged the long barrels up. They remain locked in this position, silent sentinels aiming at an enemy that has long since departed. The rust is slowly eating away at the rifling, and the steel is being colonized by deep-sea organisms, but the aggressive silhouette of the heavy cruiser remains. It is a snapshot of the moment the power died, preserved in the cold vacuum of the deep. The discovery of the Maya in late June 2019 closes a chapter that began on October 23, 1944. For decades, the families of the 336 men lost aboard her had no specific location to reference. The ship was simply missing in the vastness of the Palawan Passage. Now that uncertainty is resolved. We know exactly where she lies, we know how she suffered, and we know that she retains her dignity despite the violence of her end. The mission of the research vessel Petrel was to find and identify. That mission is a success. The unique refit configuration has been verified. The location is logged, the condition is documented. The outcome is not a recovery of steel, but a recovery of truth. The lights of the ROV fade as the vehicle begins its ascent, leaving the cruiser to the darkness. She is no longer lost. She is merely resting, her watch finally ended, guarded by the depth and the silence of the ocean floor.